Statistics and measurement. Some basic statistics. We're going to start with the basic first. So we have to define what is statistics. Statistics refer to numerical observations of almost any kind or any set of quantitative data, as in vital statistics or as used in the phrase statistics shows. It is a branch of science that deals with the collection, tabulation or presentation, analysis, and interpretation of numerical or quantitative data. This is also derived from the word statista, meaning statesman. Akinwell defined this as the political science of several countries. We have here the field of statistics. We have two. The first one is the descriptive statistics. Descriptive statistics concerned with gathering, classification, and presentation of data and the collection of values to describe the group characteristics of the given data. For example, we have the measures of central tendency. For the measures of central tendency, the most common here is the mean, median, and the mode. We have also the variability, skewness, kurtosis, and others. Second one is the inferential statistics. This aims to give information about large group of data, meaning the population as the large group of data, without dealing with each and every element of these groups. So they are being analyzed as a group. Uses small but representative portion or the sample, the total set of data, in order to draw conclusion or judgment. So you can use for the population, we can use also for the sample. Samples of this, we have the sampling. We have different methods on how to do sampling. We have the estimation, the testing of hypothesis using z-test, the t-test, the chi-square, the f-test, the ANOVA, and others also. Then the origin of this, historically, it is from two diverse interests of man. So it started with these two first before it became widely known by other people. So the first one is for politics, the second one is entertainment for the games of chance. So statistics was used before for them to determine their chances of winning. It is being used for them to determine if they're gonna win or they're gonna lose in a given event. We have here Quetelet. He applied statistical method in the field of education and sociology and demonstrated that statistical techniques derived in one area of research are also applicable in other areas. Because of the work of Quetelet, he was named as the father of modern geometry. We have the methods of data presentation. So data may be represented by three forms. We have three different forms. The first one is the textual form from the word text. Used in presenting data in paragraph or narrative form. It is simple and appropriate only when there are few numbers to be presented. So, from the word text, we use paragraph or narrative form. For example, educational attainment of PASUK and UP teachers, from the dissertation of Dr. Maria Azucena Lubrica entitled Promotion and Merit Schemes of SUCs in CAR 1996. The PASUK and the UP systems are comparative in terms of the educational attainment by the respondents. Most of the teachers are master's degree holders, that is 41 out of 75 or 54.6% in PASUK and 18 out of 32 or 56.25% in UP. So this is how we are going to present our data using the textual form. Second one is the tabular form from the word table. A systematic way of arranging data in columns and rows according to classifications or categories. Creating a statistical table is a very effective and efficient means of organizing and summarizing data because a lot of information can be seen from a single table. It can show a comparative of figures under each category. So let's have the example of this. An statistical table must consist of the following parts: the table heading, which includes the table number and the title; the body, which includes the main part of the table containing the figures being presented; the stubs or classes, which are the categories describing the data, usually found at the left-hand side of the table; and then we have the captions, which are designation of the information contained in a column. Captions are usually found at the top of the column. So we have here the example: educational attainment of PASOK and UP teachers. So this is how we are going to write our table. This is the title. We can put table 1, something like that, okay, or table A. Okay, it's up to you. Then we have here the graphical form from the word graph. So by means of graph, a graph or chart is a pictorial presentation of a set of data. It shows a general situation at a glance. Each graph or chart must have a figure number and a title. If data is based from another source, a source note should be included. Okay, so let's have these different examples. Bar graph represents the frequencies or magnitude of quantities in a set of categories. So in the bar graph, you can see here we have what we call as our label, then the title, and then the graph of each fruit. So for the bar graph, you can use the vertical bar graph, this one, or you can use also the horizontal bar graph. It may be simple or compound and can be vertically or horizontally arranged. It is used for both qualitative and quantitative data. Next one is the line graph. So from the word line, same as true with the bar graph, we locate the given numbers or the given frequencies, but instead of making bar, we use lines. So there. So we connect them, we connect the dots using lines. It can be a solid line or it can be a broken line also. It is also used for both qualitative and quantitative data. Third one is the pie graph. This is just simply a circle being divided into different parts. What's good about a pie graph is, aside from having the different parts labeled, we use percent also to represent the population or the sample in each portion. This is useful whenever the objective is to display the component of a whole entity in a manner that indicates their relative sizes. Then we have the pictograph. We use pictures or any symbol for us to represent a data. So this is the example. Okay, so the number of illiterate children. So it can be one picture, can be in terms of tens, hundreds, thousands, millions, or it can be a multiple of 5, 10, 15, 20, or it can be 1, 2, 3, 4, 5. Then statistical map show geographical locations and may contain different symbols. Okay, it is very necessary to include the legend which tells that the symbol represent. Okay, so we have here the map of the Philippines. Okay, so candidate sites for the nuclear power plant. So we have here the different places. Next one is the histogram. Histogram is associated with a bar graph in a frequency distribution table. It is constructed by marking off the true class boundaries along the horizontal axis and erecting over each class interval a rectangle whose height is equal to the frequency of the class. So as you can see, histogram is somewhat same as the bar graph. But for the bar graph, you can see also that there is an interval in each given sample or population. But in histogram, there is no interval there because of the use of the class boundaries, which we are going to discuss as we go on. A histogram quickly reveals the general patterns or distribution of values. Then we have here the frequency polygon, a simple line graph joining the midpoints of the bars of a histogram. The midpoint of each class is plotted against the frequency for that class. So a frequency polygon in representing this is like a combination of a line graph and a histogram. But upon creating the histogram, we cannot just connect the line graph, but we need to locate its midpoint, the center of this histogram. Okay, so the center being connected by a line graph. Then we have here the last one, the ogive or the ogive, a graphical presentation of the cumulative frequency of an FDT or frequency distribution table. The less than ogive is constructed by plotting the less than cumulative frequency of each class against the upper two class boundaries of the corresponding class. So we have here an example, a bar graph and then a line graph. So the points representing the cumulative frequencies are then joined by straight lines. The greater than ogive makes use of the greater than cumulative frequency of each class, which is plotted against the lower true class boundary of the corresponding class. So we have the greater CF and then the lesser CF. These are very important for us to create an ogive representation. So these are the different ways on how we are going to present a data. For your activity instruction in a long band paper, put all your activities there. So your margin should be 1 inch in all sides. Please do write your name and your course and the schedule. No need for your FB account since I got your FB account already, and no need for your contact number because I got your contact number already. Please message me for you to be added in our GC. Yes, we have our GC and I added you already. So here's the activity. In a long band paper, you're going to encode or encoded. Provide a data in tabular form and represent it in their graphical form. One tabular form is to one graphical form. Follow the methods in presenting the data. So we have the bar graph, the line graph, pie graph, pictograph, statistical maps, histogram, frequency polygon. I'm sorry, that should be polygon, and then ogive. Okay? You may use the internet for you to have your guide. So that ends our first session. Thank you so much for listening. Please do comment your name down below for your attendance. Thank you.